Welcome back again from that short break. So up next we have DaShaun and Brian with Leap Ahead with Redis 6.2 to find out more of the new and interesting features in Spring Data Redis 2.6 and the future roadmap of Spring Data Redis. Brian and DaShaun, go ahead.
I think that's us. We're here. We made it all the way to Spring 1. It feels good to be here. Yeah, thanks for coming. Thanks for joining. We're going to talk about Spring Data Redis and Redis OSS 6.2. With me is my good friend, Brian Sam-Bodden. Maybe you've heard of him, author, technologist, awesome person, and yeah, Spring Java expert. Myself, also, I'm here. I'm DaShaun. I've been at Redis for 319 days. I do stuff. I've got a family, and I enjoy. I'm really excited. I don't know if that's coming across, but I'm excited to be here. We're going to talk about some stuff. Redis. Maybe you've heard of it. It's the most loved database. Stack Overflow's 5th year in a row. The data is stored in memory, not on disk. There's a little asterisk there because we have Redis Enterprise on Flash. Less than 1 millisecond latency, 162 clients in 50 different languages. Currently, the Redis OSS Docker images being downloaded just over 7 million times per day. Redis OSS 6.2, we're calling it the Community Edition, and that's because it was driven by the community. Loads of community contributed features, lots of just new operators, extensions, some consistency improvements, 15 new commands, 5 changed, and 8 are deprecated. They're not going away. They're just deprecated in favor of some new changes. Brian.
All right. Well, welcome everybody. And I'm Brian Sam-Bodden, and I am going to jump in and talk about Spring Data. And data comes in many different flavors. And every time you're working on a framework, trying to switch the database or the underlying storage becomes very difficult. Spring Data actually makes it significantly easier than any other framework by providing an isolation layer between all the many different ways that data can be found in the wild, from graph databases to key value databases to document databases. Spring Data is a family of projects that allows you to connect your data to a Spring application. And it provides a lot of different things. Most importantly, it's that it's pure Java and it's a Spring idiomatic. So it feels like you're working with Spring. Even if you switch databases, you're going to feel like you're still working in the same type of mode. It provides from low-level constructs to high-level OO abstractions, and it provides all the newfangled reactive, non-reactive, and functional-ish interfaces. Obviously, object mapping, it's built in for most environments. And the powerful concept of data repositories is available to you to be able to use the familiar DAO-like abstractions. And on screen, you'll have the URL if you want to learn more about Spring Data. And today, we're going to be talking about Spring Data Redis. In Spring Data Redis, and I'm going to be calling it SDR for short in the slides, it's part of the Spring Data family, and it's one of the most complete Spring Data projects. It provides a super easy configuration to talk to Redis, and it gives you all the low-level connectivity that you need using 2 of the main drivers, which are Redis and Jedis. And it also provides Redis templates, which will give you commands per data structure in Redis. And we'll talk a little bit more about data structures in a second in here, but the Redis templates are going to become, they become very, very familiar to Redis developers and Java developers because they kind of give you that connection to the innards of Redis. But once you get past the command-driven thinking or operations, then you can actually map your objects using key value mapping from objects to repositories. And Spring Data Redis makes that super easy. One single annotation currently, Redis hash, which basically makes the job of mapping a Java object to a Redis hash as simple as it could be. Next slide, please.
Awesome.
All right. DaShaun has strings now.
There's a bunch of different data types inside of Redis. And the first one, kind of the most popular one, is this string. It's what we use for our caching use cases. And what I'm going to do is walk through. It's same pattern across the board. I'm going to show you some of the commands that are inside of Redis, available by the Redis CLI. And then I'll go into like, hey, what does it look like using Spring Data Redis? So first, I'm going to store something in Redis. And after that, that's me running the CLI. After that, I want to pull something out. But this is what I'm going to do. I'm going to take that same command where I want to set one of my keys inside of Redis, and I'm going to turn it into a Spring Cloud function, trying to keep it a little bit interesting. So this is what it looks like in that same command here. That same set command that I did on the CLI is available, just like you would expect. Now, I've deployed that. It's running locally. I have it running, and I'm going to do my little test. I'm going to call that Spring Cloud function, and I'm going to see that it works. Hey, we're doing things. The next thing is I want to get it back. So I've put a key in, and now I want to get that key back. I'm going to do it from the command line. Hey, I got my value. Same value I put in just a second ago. This is what that Spring Cloud function looks like. So I have these commands. I have this super fast data store. And for me, when I was thinking about what is this going to look like? What do we want to show? I automatically went to these Spring Cloud functions. I want to have that thing that just goes really fast. It can scale. It can be serverless, just like my data store. And this is what it looks like to get that value that I pulled out. I'm passing in my function, passing in the string for the key that I want, and I'm going to pull it out. And here I'm using the string Redis template. And I do that because it handles a lot of the serialization. I don't have to think about a whole lot of things because Spring Data Redis does it for me. Let me test my function. Yeah, it worked. This is where it gets interesting. I have a lot of conversations. I do work at Redis, and I have a lot of conversations about speed, performance. And sometimes 2 milliseconds is just not fast enough. Why would I want to make 2 calls to go and get an object and then update it? Why would I want to do that? That takes maybe 2 milliseconds. This function, this new command allows me to make 1 call. I want to get the value, and I want to set it with a new value. This is what it looks like. Let's test it out. From the command line, what I'm showing you is that, hey, I've set a value. Here's my first value. It returns OK. It says, yeah, you did that. I want to get it. All right, I have my value. But now this time, I want to get it, and I want to update it with 1 call, 1 command. And that's what we're showing. I got the first value, and I updated it. I called it again just so you can show. I'm going to do the exact same thing, another Spring Cloud function. So I can make 1 call to the get and set. So I can have that sub-millisecond latency. Here it is right here, the new function. It's available. We're using the Spring Data Redis 2.6 milestone 2, which is awesome. It's fun. Explore the milestones. Take them for a spin. Living on the bleeding edge is okay as long as you know how to heal. We all do the CI/CD. We know how to deliver things. And it's okay. If your workload works on the milestone, take it for a spin. I'm going to run my Spring Cloud function again. Things are working great. Mark, thank you so much for the great work that you put in. It's just fun. It's fun to know that Spring Data Redis follows so closely with the product. Another new feature, another new command is the get and expire. Why would I do that? Well, we're going to call this a self-destructing message. After I get it, that feature that I'm going to deliver, once I grab that message, it's going to self-destruct. This is what it looks like. I grab it. I'm going to go ahead and check the TTL so you can see that this is really happening in real time. And then when I ask for it again, it's no longer there. This is how I'm going to deliver the same command using a Spring Cloud function. Let's test it out. Things are working. This is great. Hopefully it's not there. I didn't handle my errors correctly, but yeah, beginner track. I did that on purpose, totally. Get and delete, another self-destructing example. There's use cases like 1 time per customer. This is what it looks like. Same thing. It's an easy use case. But again, who wants to call things twice? Milliseconds matter. This is what it looks like in my Spring Cloud function. Let's run through. I know I'm racing through these slides. I want you to be able to see the code. I'll slow down on that. but I'm running. It's possible to take this product and get all of the latest features, even in this milestone release. Things are working. I have this one-time use token, AKA OTIT. Try that. It'll catch on real soon. OTIT. So we can now expire things, not just on the milliseconds and seconds. Now we can say, I want it to expire at this time. And I can do it with millisecond, what's the word I'm looking for? Precision, or seconds precision. This is what it looks like from the command line. I say, I want this to expire. This offer is not going to last. And I set it to September 3rd, 2022. Let's see if that works. And it looks good. So I set that expire a year from now. And we can see that, hey, that's about a year from now in seconds. And then I'm going to show you the TTL. Hey, there it is. And now I go ahead and set it again. And this time it's going to expire at the seconds. So this was the milliseconds example, and this is the seconds example. Again, it's the same on the TTL side. This is the millisecond precision example in a Spring Cloud function. So those commands that we're seeing, this one was not actually implemented the way that the other commands were. So I found a workaround. It's because it already existed. There's already a feature similar to this in Spring Data Redis before. So we were able to just kind of leverage that same existing example, that existing code. We didn't have to leverage the command. But I implemented. This is still what I want to do. And this is what my command looks like. Let's test it out. I got a little sleep in there just to make sure, hey, I set it, and I'll scoot that over. I set it to expire 2 seconds from now. So that's where I grabbed the current date and then it expired. So we're just getting started. This is just strings. This is just an example of how we can deliver the same Redis commands via Spring Cloud function. I'm going to scoot through these because the really, really good stuff is coming up. So it's quiz time. If you were paying attention, you might have heard, what is the maximum size of a Redis key? I'm just kidding. I didn't tell you, but take a guess. If you're dealing with NoSQL databases like Redis, you have probably run into limitations on what size of objects you can store. And sometimes that becomes a limiting factor. That's why I bring it up. In Redis, the key can be 512 megs. Wow, right? What do you think? You got to be thinking, like, mind blown. But now, what about the value? Remember, this key value on this string object specifically. How big can that value be? It's also 512 megabytes. Now, I wouldn't recommend throwing a bunch of those 512 megabyte keys or values into your database, but you can. Hash. This is the one. This is the one that kind of changed the way I think about it. My good buddy Colin, he said, hey, you know what, DaShaun? The way that I think about Redis is it's kind of like a heap that I can make really, really big, and I can store these objects in it, and I can manipulate them really fast, just like it's in my local heap. And this is the object that really connected the dots for me because it's so similar to a Java map. I can actually store 4 billion field value pairs inside of one hash. And that really gets my mind racing. I've done a lot of work over the years, and this is one where it just connects the dots. What does that look like? Well, we have some operations. We're going to set a hash. We're going to set some fields on it, and we're going to take a look. So far, so good. So I added a status track, some fields, and then that's just their values coming back. Current time. And I grab all of those fields and values. Easy enough. This is what it's going to look like. This is my H set, where I'm going to set one field at a time. This is my HM set. I'm going to set multiples. And here I'm just passing in a map, and I'm pulling those values out. And this is my HGetAll. Get the hash and all of its fields. We'll run it. Things look good. Start.spring.io. Leap ahead with Redis 6.2. This is the new one. This is the new command available to hash. Again, community driven. It allows me to have up to 4 billion fields, but then grab random fields from that hash. This is what it looks like. I put in some fields with my HM set, and then I grab 4 randoms. When it's a positive number, that's going to have, it will allow duplicates. I didn't get any that time. If I do a negative number, it will force no duplicates. So it'll be truly random. This is it's the same thing. We're doing CLI, we're doing commands. We're just implementing them as Spring Cloud functions. I can also get the values back. And let's give it a spin. So here I can see that I got my fields, and then on the last command, I grabbed it with their values. My mind is blown. What is the cheat code? The cheat code for you is don't try to remember those commands. You have Spring Data Redis. And with that, I'm going to turn it over to Brian.
All right. So let's see. Let's talk about lists and what has changed on the list. But before that, I'll give you a quick introduction in case you haven't played with Redis much. A list is an order sequence of strings, very similar to a Java list implementation like array list. And the difference is that the Redis list, it's a super multi-purpose list. It's implemented as a linked list, but it has enough commands to turn it into a stack, into a queue, into pretty much anything linear storage that you want to create. It can hold up to 4 billion entries. So how do you add things to a list? There's many different ways. You can push things from the left, from the right. You can push them if they exist. You can push them if they don't exist. You can insert things before and after a specific element. And you can also set the value at an existing index. So some of those commands are the ones that are basically being used from many different frameworks to implement different data structures just backed by the Redis list. So how do you remove things? You can pop them off. You can pop from the left, pop from the right. You can block and pop from the left or the right. And this blocking behavior is something that it's very unique to Redis. And it's very suited to implement messaging and wait for a message type of environments where you can basically sit there and wait for an element to appear on that list so you can pop it and use it. And you can also pop things by value. You can remove things by value, and you can trim a list to basically satisfy. Let's say, give me the last 5, from index X to index Y in the middle. Very flexible. And accessing elements, obviously, you want to get to the stuff that you put in the list. You can do it by index, or you can get ranges out of it. And another one of the things that actually lends itself to messaging application, it's being able to move things between lists. So you can take the last element from one list and make it the first element of another list. You can pop something from a list and push it into another list. So all of this fine-grained commands allow you to implement very complex interactions between 2 locations that have data. So you can think of 2 lists being in 2 remote locations and having these commands being used to determine how you basically take messages from one list or a queue and consume them in the other end. All right, so in here we have an example of our pushing or creating a list with a set of funny words. And we're adding those 3 funny words in there. And then we're doing a range to basically get the whole contents of the list. Once we have a list in place, we can, again, do a range. We can push a new word into the list and verify that the list actually contains the elements that we added. And now you can see that I can use a range to get something specific. I can get from element 1 to element 3. I can insert something before a specific element on the list by value. I can set something, for example, if I do a -2, you can see that we're adding something from the end 2 elements off. So a lot of flexibility on how to modify, manipulate, transform, and move data between lists. Now in here, you can see that we can pop things with the lpop, pop something from the left side of the list. And that kind of gives you that, that kind of queue behavior that you're expecting to have. So in Spring Data Redis, to actually use all these commands, and I am going to here jump off the cliff a little bit and tell you that using Redis with Spring Data Redis is actually easier than using the commands, because we tend to kind of create somewhat of convoluted names. They typically start with the first letter of the data structure that we're dealing with, and then a combination of words abbreviated in sometimes strange ways. The nice thing about Spring Data Redis is that they basically use full-blown the full-blown English language. So you have methods that actually match much better to how you would remember that command. So to actually use some of the commands via the Redis templates, you first basically inject a template. In this case, I'm injecting a string Redis template, which takes care of already of basically telling Redis that my keys are going to be Java strings and my values are going to be Java strings in the specific case. And once I inject a string Redis template, I can actually get operations from many of the different data structures. In this case, I'm declaring a list operations that comes from that Spring template. And then inside of my method, I can actually now use my operations to do a bunch of fun things. For example, in here, I'm going to do a write push all. So for example, in the Redis command, sometimes you have to pass how many elements you're going to insert when you have a multi-element command. So for example, you would say, I'm going to do an R push 3 elements and then actually list the 3 elements that you're going to insert. With Spring Data Redis, it's just a single command, and we're basically using the power of Java to have the first element of the method be the key for our list, and whatever comes after that are going to be the elements we're inserting. Notice that the range command that we used before, it's also available here. It will return a properly typed list of strings based on that Spring template that we use, which is using strings already. We can turn that into an array to print it. We can push things to the left. We can get ranges like we did before. All of the things that you expect to be able to do at the command level with Redis, you can do with Spring Data Redis. And not only that, you can actually do transactions. You can do all the things that you expect to do with Redis in a much more idiomatic, type-safe way. So what is new in with lists in Redis 6.2? So we added an L move and a BL move. So every time you see a B, it's going to be a blocking command. So you can do a list move or a blocking list move that can pop or push arbitrarily things. And we also added a count argument to the list pop and left pop and right pop. So L move on the CLI, you can basically take the rightmost item from one list and move it to the left of another list, or insert it on the beginning of the other list, or take the leftmost element of one list and put it in the front of another list. So fairly simple. Here's an example of doing that. We're using rpush with list 1. We created a list with 3 elements. And then we can use these flags right and left to basically do specific things on how we move elements between lists. So notice in here that we modified list 1 to move things to list 2. So we now end up with a modified list on list 2 by moving things around with this command. And again, if you use the blocking command, you can imagine this being in a messaging scenario where you're blocking, waiting for a message, and then you basically move it once that message arrives.
I'm going to fix that because I want to. I'm going to delete that key. And I'm going to delete this other key.
Thank you.
And I'm going to rerun that. That's what's up.
Done and done. Live slide modifications with code execution. All right.
Demo,
so,
right? It's live demo.
Thank you, DaShaun. So here we have that same code, the lmove code in Spring Data Redis as a JUnit test. So I took a different approach than DaShaun. DaShaun did Cloud Functions to basically highlight some of the cool things you can do with Azure in our cloud capabilities. And in here, I'm basically going in a more TDD programmer exploring fashion. And I'm writing unit tests. So I have a test here called test lmove, where I basically did exactly what I did on the command line. You can see that the Spring Data Redis commands, again, map very closely to what you have in Redis native commands, but in a more legible fashion. And another change that we have with list, it's adding a count to the left pop and right pop. And basically, it allows you to pop multiple things. So let's see that on the CLI. And in here, we have, we're pushing 3 elements onto the right of a list. And then we're popping 2 elements from that list. And now we check the list at the end, and you can see that we should have a changed list now when we basically look at my list. All right. So to do the same thing on Spring Data Redis, again, super simple. I can do the right pop. I can actually replace those 3 commands with a single line too, because in Spring Data Redis, I don't really have to pass. Sometimes we don't use the commands that take multiple elements because we have to be redundant in listing the number of things we're passing. So sometimes we're lazy and we don't want to count if there's too many of them. We just copy and paste a bunch of lines. With Spring Data Redis, you don't have to do that. You can basically pass the commands as a var args, and it'll be happy. So in here, you can see we do the same things. So now let's talk about sets. Oh, we're good. So sets, like lists, are a linear collection of elements. The difference with a set, it's that the collection, it's unique. The elements are unsorted. And the set operations allow you to do a lot of interesting things. Kind of like a single version or a simple version of a non-matrix linear algebra. You can do union, intersections, subtractions. Most of the operations are constant time or linear time in some cases, but most of the ones are constant time. So what are the use cases that we would use a Redis set for? Unique item management. So the one super common would be tags or folksonomies, where you have a tagging system. And Spring Data Redis allows you to have, really up to 4 billion set of tags, tracking unique IPs, content filtering, a lot of things that you can do with uniquely counting or determining uniqueness in a set. The set, it's a very important support data structure too when it comes to object mapping. For example, in Spring Data Redis, Java objects are mapped to Redis hashes. But to be able to manipulate collections of objects, we keep the primary keys in a set. So that allows you to basically do all the operations that you expect when you're dealing with a primary key or multiple primary keys. All right, so working with sets, you can add things, you can remove things, you can access them, you can access all the members of a list, you can access a random set of members, you can scan the list. That could be expensive, so you gotta be careful with that one. You can check the cardinality of a list. And here's another example of where actually using idiomatic Java, it's sometimes better than using a command. I always look at scard and my mind has to jump a couple times before I realize it's like, oh, cardinality, counting. Oh, it's the size. It's the size method. In Spring Data Redis, it is the size method. So it makes more sense sometimes. And so we have sysmember to check membership. And sometimes you basically would say sysmember, which sounds funny to me. And then the next one is mismember. It's even harder to read. So all of these commands actually sometimes get combined in Spring Data Redis, and then you use a flag or determining or based on the contents of the parameters, you determine which commands to use under the covers. You can also do a lot of operations to basically differentiate a list, find the intersection, union, or move things between sets. All right, so here's an example where we're basically creating a set of colors, And notice that we're trying to add the color yellow again. And notice that the return values, when we add something unsuccessfully, we're going to get a 0 back. When we add it successfully, we're going to get a count of what things were added successfully. Notice that if we check do the is member on the color set for green, we're going to get a hit, which it's a 1. In Redis, just like in old school C, a 0 it's false, a 1 is true. Same thing if we hit the magenta element, which is not in the list, we're going to get a 0 back. And notice that we can now remove things. We can remove green. We get a 1 back because, yes, it was there and we removed it. We try to remove it again. It's going to give us a false because it was not there anymore. And again, we can check the members of the list at the end, and we get our set of colors that were remaining in the set. All right, so how do we do this in Spring Data Redis? And it's actually, again, super simple. Notice that I try to mimic the command CLI examples, but some of this stuff can be done in a much abbreviated fashion, especially if you start using Java collections appropriately. Again, you can use streams and all the things you're used to. In here, I'm doing more of a one-to-one to what we have in there. But notice that I was able to, for example, do a members, and I get a type set. So it basically put things in the right Java collection too. So things that are list in Redis will return a Java util list. Things that are sets in Redis will return a Java util set. So everything makes sense and it plays very well with what we have in Java. Okay, so what have we added to sets in 6.2? So the is member, the only addition really, it's a is member can now check against multiple things. So let's take a quick example on how to do that on the CLI. And you can see that I have again, another list of colors, and I'm checking for membership on red, black, and green. Black happens to not be in the list originally, so I get a 101. So a yes, nay, yay. And that's actually how SM is member works. And again, you can say that twice because it's hard to throw an M in between something that you were used to saying sys member. So I was like zim member. All right, next. So SM is member in Spring Data Redis, it's super simple again. They just did not really have to override thing. I have basically a very simple is member method that before used to take one element and now can take multiple ones. So the same method using 2 different implementations of a Redis command under the covers. So that's the actually powerful thing of basically having the ability to overload methods, had var args in Java, and the Spring Data Redis team has done an amazing job of basically mapping this thing in the most sensible possible way. All right, so in here, we're flushing the database because we're brutal, and we're adding more things to our list. And notice that I can do an SM is member, passing all those different colors, and I get my result as expected. All right, so let's talk about sorted sets. In sorted sets, it's kind of a hybrid. It's the Liger of data structures. It's a combination of a set and a hash. And you can think of it as each value being a tuple that has a value and a score. So in a lot of cases, it behaves just like a set, but when you take things out of it, it behaves like an order list. And you basically can take things that come out of the sorted set come out sorted by that score. And again, yeah, retrieving ranges in there is when it gets really powerful because you can do things like leaderboards and top 10 most popular songs in your database, etc. And I jumped ahead. So the use cases, priority queues, low latency leaderboards. Again, some of these applications, the reason that Redis is so popular for this type of application is because, first of all, it has simple data structures that developers can understand, and it's fast as hell. So combine that with a very easy to use framework like Spring Data Redis, and you have a winning combination. So in here, we have a secondary indexing, again, actually in Spring Data Redis, we use, I believe we use sets for secondary indexing, but sorted sets will probably be also a pretty powerful way to implement a secondary index. So in this example, we're doing a sorted set add. Notice that it's a ZAD, and we basically add multiple elements in Spring. In our Redis commands. One thing that I don't like is that we typically put the weight first and then the value, which makes no sense to me. I think we should probably put the value and then the weight of that value. But I'm not going to bring that up because I can get in trouble. And notice in here, I can do a Z range, so similar to a range in other commands on game 2, but I can then say, hey, give me all of the elements with scores, and they should come out ordered by their scores. Excellent. So now you can see that I can do, for example, the intersection of 2 of this game. So we have players in 2 games, and now I can intercept those games and see who was playing in both of the games. I can also notice that when I do a with scores, I'm going to get the aggregation of the scores of Frank. So for example, Frank had 100 and 200 in 2 of the games. And the intersection with scores gives me 300, which is basically the combined scores of the 2 games. And if I do an aggregate and I pass the max flag, now I'm going to get the maximum score across all the games that I actually intersected. So in this case, will be 200. And the last piece was the difference. And thank you. So in the difference, I can actually basically see everything that was in game 1, but not in game 2, or every player that was in game 1, but not in game 2. And again, with scores, just basically throws the scores in there in case you need to manipulate those. And again, notice that everything that comes out of the sorted set, it's sorted by the score. How do you do this in Spring Data Redis? Super simple. I noticed that we have a type tuple, which is a Spring Data Redis type created by the Spring Data Redis team, that basically now we can return a tuple of a set of those tuples when we do all of our sorted set operations. And the cool thing again is the type tuple takes the value, the name of the element, and then the weight, which makes much more sense to me. Notice in this case, I use the set off operation or a method to basically create this collection of tuples, and then I add them with the cset operations add method. So to do the C range in Spring Data Redis, again, super simple. I have my Z set operations. Again, remember, all these operations come out of the Redis template. So I had my string Redis template, which basically says, hey, I'm using string keys and string values, and I can say, give me the operations for sets. And now those operations come out of that template typed. So I can actually work without worrying about bytes and all that stuff that it's below the level of abstraction that we want to work in. So in here, notice again, we're doing the same thing, range with scores. We're doing notice that I can do obviously an iterator over the set that it's returned back. I'm just grabbing the first element in there just to check the values that Frank had in that game. In his max score in across all the games. And again, super simple, super simple. So to do the intersection in Spring Data Redis, again, we have an intersection with scores. Notice that it's the same method, and I just pass an aggregate.max. So there's an enumeration there that allows us to basically pass these flags to modify the behavior or even the command that's being used under the covers. So super simple. You're manipulating sets. You can have your iterator. You can basically get a stream out of it and do all your lambda transformations that you want to do. Very, very idiomatic to Java. And again, remember, this is still low-level Redis, but with a nice veneer of Java on top. So same thing with the ZDiff. In here, I'm getting the differences between the two game 1 and game 2, and basically that will get me back the players that were only in game 1. Super simple. Notice I use my assertions in JUnit to basically say, oh, a players contains all of the set of these players. So all of the ways that you're used to work with values in Java will map perfectly well to collections with Redis. All right, so what has changed in the sorted set? And I'm going to move pretty fast through this. It probably would just show one of the examples in here. But The CM score now can basically take an array of scores. So notice in here, I am basically doing a Z add 2 values, and then I'm doing a CM score of my set, passing 1, 2, and something that doesn't exist in the list. And it's going to tell me, oh, here's the score for the first one, for the second one, and nil for the value that doesn't exist. In Spring Data Redis, you're going to get a null value in there. So, you're good to go. Notice in here, the assertion at the bottom, I have a 1 double, a 2 double, and then a null value. So very easy. Just don't type the list if it's a higher level object that you're trying to store in there first. You start to get the raw thing, see if it's null, get the nulls out, and then transform. All right. So again, the changes in Spring Data Redis assorted sets are very powerful, but are very succinct. It's things that are going to affect mostly people that already implemented something difficult with sorted sets, and now they found like, oh, they finally did that, and it's going to improve things in terms of complexity or performance. So I think we can move now to the end of the sorted sets, and let DaShaun kind of jump in a little bit so he can have some time.
This is it. You said so many things here. We'll scoot through. There's definitely 2 ways of approaching this. You can go test driven, or you can just YOLO and, hey, let's send those Spring Cloud functions into the cloud and go. It's examples, but you also said fast as H word. My parents are watching this. The geo data type is actually built on top of the sorted set. I used to work at a company that did a lot of things around geo data. Latitude and longitude are encoded as the score. That's what's happening there. And it's really, really neat. The one thing, if we're complaining about what's going on, they put, I'm used to lat long. Well, here it's long lat. I don't know why, but that's okay. I still love it. Let's do some stuff. I'm going to put some events, some spots, some points into my geo. And I can actually add them. And then I'm going to grab, hey, what's the distance between those two? And if you'll notice, these are actually pretty close together. The hash is actually really, really fine-tuned. You can actually do really good value searching. You can actually like walk along a trail, walk along a sidewalk, and capture those actual values really well with that data type. This is what it looks like. This is my geo add. It's the same thing. I'm just running the command. I'm putting in long lat. But let's test my Spring Cloud function. Things look good. I'm going to keep on going. I can do the same thing, but pay attention. I want to do a geo search here. I did a geo search. Are you paying attention? Were you paying attention? Because I used the Z range command. I didn't use the geo command. It's still a sorted set. I can still use those commands. Look at this. There it is. See, that's not a geo command. That's a Z range command. Streams. We fixed a lot of things in streams. Actually, there's one that really matters. Where I want to trim, what we had before is we could only trim based on a number of entries. But the IDs are coming back in milliseconds. They have a millisecond ID associated with them, and we fixed that. That's a big deal. That's the biggest deal. This is the most important thing. But we're going to scoot past this, and I'm going to point you to Simon's Head in the Cloud video so that we can get into a demo. Let's see what this looks like. Let's understand what it's like to work with this this new data store, this fabulous fast data store, Redis. So I'm going to kick it back over to Brian, and let's dig in and watch our language.
All right. So I forgot. What are we doing now?
Yeah, you're going to do your demo.
All right. So
I'm going to stop my share.
Actually, DaShaun, do you mind putting the few slides that we have in there? Because I really want to show the slides first, and then run the demo in the last 5 minutes.
Absolutely.
Because the annotations, seeing the annotations in context is going to make sense.
Teamwork makes the dream work.
Here is what we are actually working on at Redis recently in terms of client libraries and making the developer experience better. And we're trying to, obviously, Spring Data Redis has done an amazing job of simplifying how we use Redis from a Java application. And what we're doing at Redis It's taking what Spring Data Redis has done and extending it to basically provide access to some of the modules that we have created over the years. Some of these modules include our JSON, Redis JSON module, basically which gives you a full-blown document database inside of Redis. We also have Redis Graph, which gives you a graph database inside of Redis. So imagine if you have a graph database and a document database and a search engine all under the same umbrella. The things you could do. And those things you can do now with Redis. So we have in the work that I've been actually spending some of my time on, it's figuring out how to do what Spring Data Redis did for OSS Redis for the for the Redis modules. So one of the very important things we're working on, it's basically multi-model object mapping support. Can I have a collection of Java objects that all point to different types of data structures in a database? An object graph or a directed graph, a JSON document, an aggregation coming from a search query. There's a lot of different things that can be done with that. Also, integration between those modules is where things can get really interesting. For example, we're looking into integrating, or we integrated JSON documents and search together. So now you can do searches over collections of JSON documents. And obviously, graph objects being mapped to Java objects makes a lot of sense. So that's in our purview. And again, the Redis search integration across Redis hash mapped entities. So if you have a Spring Data Redis application that's using Redis hashes, we're going to give you some annotations so you can actually now add powerful search indexes over those mapped hashes. So we're doing some other things too. So this is kind of like the base level entry point to actually do fun things. Then over the years, we've noticed that the community has come up with amazing ideas of how to use Redis in specific use cases. And typically this boils down to a collection of commands chained together in very specific ways. And by learning how those commands have been used by the community and finding out possibly things that we can do better because we have access to the backend in Redis, we actually are working and encapsulating those use cases in ways that can be used very simply from something like Spring Data Redis or Spring in general with an annotation. So things like graph object mapping, integration with Redis search and Redis hashes, and encapsulating use cases across the board. We have, for example, Bloom filters. What if I could tell my Java application that when a certain collection of objects or certain database table gets bigger than certain millions of objects, no longer use a traditional SQL query to search? What about if we use a probabilistic data structure so we can get a good enough answer in terms of performance? So we can move fast through peak times. So we're working on a lot of really cool things that will allow us to basically be able to have more intelligent applications when it comes to dealing with large scales of data. All right, so we have a set of module templates which follows the Spring Data Redis recipe of operations for X. We saw how we can basically pull those operations for the OSS data structures in Redis from Spring Data Redis, but we're adding the same facilities for all the modules. So there would be operations for JSON, graph, search, AI, Redis Bloom, and time series. So here's an example of something that we've been working on. This Redis modules operations, and all these names are bound to change, but the idea is to basically make everything very idiomatic and to follow the Spring Data Redis recipe that has been set. And we are not, we don't replace Spring Data Redis, we extend Spring Data Redis. So it is a dependency in what we're doing. So in this example, I have operations for graph, and I can actually do things with a graph. I can basically do a cipher query against a graph stored in Redis graph in Redis. So this one is one that I'm very excited about, which basically gives us this Mongo ability to basically map a Java class to a document in JRedis JSON. And you probably have seen this add document annotation in other places. This just happens to be one that is specific to JRedis JSON. But we're using the same ID annotations, non-nulls from Lombok. Everything will look the way that you expect it to look, but it will be stored in a JSON object in Redis JSON.
I told you to watch your language.
Yeah, that was some dirty words in there. Not only are we doing the mapping, but we're also adding the repositories that you expect to have automatically, magically created for you by just declaring an interface. So in this case, we have a Redis document repository that you can extend type to the specific key in the object that you're storing. And if that object is annotated with the add document annotation, then we're going to do all the magical things you expect from Spring Data repositories. And here's an example of using a repository. We have an AutoWire company repository, which happens to be a document repository for Redis. And we can save objects, we can count the number of objects, we can retrieve objects by ID, all the things that you expect to have with Spring Data family of products. And here, the Redis search integration, this one also was very fun to actually work on. And you can see that you can add annotations they're not triple X annotations. That was just a placeholder because there's many different types of fields that you can index in Redis search. So there's text indexes, tag indexes, tag fields. And in here, you can see that I can add those annotations to my Pojo and have it create automatically a Redis search index. Then with an index in place, I can take my repository now, my traditional repository using Spring Data Redis, and annotate my methods just with the signature and the add query annotation and aggregation annotations, which basically take right now a native Redis search queries and aggregations. And once you have that in place, then those methods will basically do all the magic under the covers of hitting the search engine, getting those objects back to you and serializing them in the way that you expect them to be serialized. And we have 3 minutes. So I would say let's do the demo in the QA room. If anybody's interested in seeing some of the demo. But again, one of the things that I wanted to highlight is that part of our developer advocacy is to basically make Redis closer to the developer's way of thinking. And we have amazing stuff at the low level. If you love Redis already and you have been using commands for a while, you're probably a master dicing and slicing and chaining those commands together to do amazing things. But if you're not, we want you to basically get the advantage of using the fastest database out there by encapsulating those recipes or wrapping some of those things in ways in a package that can be easy for you to use with your applications. And now I'll throw it to DaShaun to throw some closing words to.
Yeah, we're looking forward. So 2.6, Spring Data Redis, milestone 2 right now. GA is coming November. Look forward to it. I'm always learning still. Even today, even though we've practiced this a dozen times, I'm still learning stuff from Brian. There's tons to do. If you are comfortable and you've taken the Spring Data path, for me, it was easy. Which data store do you want me to use? As long as I got my Spring Data, I'm good. I really don't care what the backend is. But also, with microservices, we want to have the right backend for the job. So take it for a spin. If you're comfortable with Spring Data, try giving Spring Data Redis a try. I think that you'll like it. And one of the things is, this is milestone. One of the best parts of this community, of the Spring community, is when you get to contribute. Contributing doesn't have to be code. Take it for a spin, give it a try, and just provide your feedback. Creating an issue, finding an edge case, that's super valuable to the community. But let us know. This is me. I'm DaShaun. My good friend, Brian.
Thank you.
Thank you. Thank you so much.
Hi there. Thank you so much, DaShaun and Brian. That was an awesome presentation. I feel like you guys could have a podcast, especially all the nice comments I saw. DaShaun seems to have a lot of fans. So maybe you guys might want to make a podcast. If you want to
Ivan, will you come
talking,
on? If we have a podcast, will you come?
I would, for sure.
All right, it's a date.
It's a date. Let's do it. So people are probably want to keep talking to you all. So if you want to continue the conversation, please head over to the Q&A. That's in the Slack channel. You can see that to the right of your screen. You can click there and you'll find the Zoom link in there. And you'll open up a personal Zoom so you can talk to them. We have Mate and Mache talking about Spring Boot on Amazon Web Services with Spring Cloud AWS. It's a community project that helps developers with the rich ecosystem of AWS managed services. So please check that out. We'll see them at 3:05 Mountain Standard Time. So see you after the break, and you're welcome to join the Q&A to continue to talk to DaShaun and to Brian. Thank you all. Bye.